Today's success criteria was really looking at multiplying fractions by whole numbers. And so the first thing they had to be able to do is, because I wanted to use not the standard algorithm, but repeated addition, they had to be able to add like fractions. So I needed to see that they could add like fractions. I also wanted to make sure that they could, of course, come up with an accurate product, an accurate answer. But beyond that, could they represent it in different ways? Could they represent it as a fraction greater than 1 and a mixed number? And then also, could they model it? And that model be accurate enough that they could truly justify the answer that they had. The reason I focused on really 3 or 4 out of the 5 or 6 pieces of success criteria is because that's what really kind of tied to just today's lesson. The one about representing, to be able to add like fractions, that was for a previous standard. So that was when I did feel very comfortable coming in that they would be able to do. But I wanted them to know that that's background knowledge they needed to be successful today. That is a progression towards what we're doing today. So we come to the next one. I can solve an equation with a fraction, multiply it by a whole number using, what do you think we're going to use? Repeated addition. Okay, so now we're getting into where we're going to be working with the StoichyyCom environment. Having said that, before I do any direct instruction, can you think about what that would look like as repeated addition? Think about what you did for 4 times 3. If you were going to do 1/10 times 5 using repeated addition, write down your dry erase board what that would look like. You don't have to solve it. Right? Just what would that look like? What problem would you have to solve? At the end of the lesson, when I'm trying to evaluate did today go well or not, the 3 that I really need to see is, can they model it? Can they use the repeated addition and to match that with a mixed number and fraction greater than 1? 14/8. All right. How can we put 14/8 in the answer blocks? How can we model that up here? What's one way, Avery?
Put one hole in, and then that's 8 and put 6 8.
Okay, so why one hole?
Because
I know.
the hole is 8.
A hole is 8/8 in this circumstance, right? So 8/8, go ahead and do that for us. So come up with another way. Everybody on their board come up with one other way to show this. How else could you show 14/8 besides one hole and 6/8? I do want them to explore the success criteria. I want them to discover what it is that I'm trying to accomplish today. What is my goal for today? At the end of the lesson or at the end of the day, what should I be able to do? And so making them part of that conversation is actually going to help them retain it even more. So they say, oh, I know because we helped make that or we helped create that. And so it resonates with them when one of their peers or themselves come up with it themselves. So let's have a conversation about some of our success criteria down here first. I can represent the product as a fraction greater than 1 and a mixed number. So what is the fraction greater than 1?
3 3/8. No, 26/8.
Which is it? What is yours then? What's the difference between a fraction greater than 1 and a mixed number? So how can I quickly decide if a fraction is a fraction greater than 1? Ava?
If the numerator is greater than the denominator.
Is that true? Yes, if the numerator is greater than the denominator, it's a fraction greater than 1, right? Because once they're equal, what happens when the numerator and denominator are equal? It's one whole. So once that increases, now we're above one whole.